Okay, welcome back to the lathe build. And the last video, I screwed up that 2 times. What I decided to do, this was my second attempt. Like I said, I called him and told him I screwed up, and they sent me another one. This was my second attempt. This one is actually not too bad. This one came out pretty good. I just had a little bit of an issue on one of those coins. Yeah, it was that one. A little bit of an issue here where when I started to cut, it shifted because I wasn't clamped down very well. But other than that, this thing is pretty much very almost perfect, and I'm very pleased with that. And so the one I screwed up, if you don't remember, the T-slots were way too far off from in line with the bosses, and one of the T-slots broke through the side, and it would have been, usable, I guess, but I just didn't like it. And so what I decided to do was I put that one back in a lathe, and I just turned the back off. I just turned down the back castings there just so the slots were all the way through. Now, I was thinking about that, and I was talking about this with a colleague of mine at work, friend of mine at work, and he said, why didn't you just turn the back off? And I'm like, okay, so I guess my idea wasn't completely stupid since somebody else had the same idea. Now, before I did that, I did some image searches for faceplates just to see if there was one that was exactly like this. Basically, 4 slots that don't go to the edge and 4 slots that do go to the edge. And I did not find one exactly like that, but I did find several examples of faceplates with 8 slots that went all the way through. Some with 6 slots, some with 4 slots, some with just one straight through the middle and one off to the side, some with just holes. So there are countless versions of these. And just because I did not find a picture of one just like this, I obviously did not look at every single faceplate available. So I'm going to say it's possible that there is one like that. So anyways, I have 2 different types of faceplates, and I'm actually tempted just to chuck up a scrap of aluminum and make a different one. Maybe one with like 3 or 4 slots, or maybe one with just some threaded holes, just so there's a variety of faceplates. So yeah, that's what I did with those. These are finished parts. And so I want to get back on the lathe. Obviously, that's why we're here. I don't really have a ton of free time right now because I'm also trying to get the Nimitz build finished. But I did find myself with a little bit of free time. What I wanted to do next was this. The bed. I wanted to do the bed next, but this part is going to take me quite a while, and I didn't want to put the Nimitz on hold for a while I did this. So I decided to just do another really simple part, and I decided to do a part that has been on my mind for a while just because of what's required of it. And that's this right here, the feed shaft. Now, there's really only a couple of operations that need to be done. It says it's 1/8 diameter cold rolled steel. That came in the kit. That's what that looks like. And 6 3/8 long. It is just a little bit longer than it needs to be. You'll notice when they chopped it off, the ends are kind of pinched where they cut it. So I'll need to do some lathe work and clean those ends up and bring it to length. I'm going to do that later. I'm not concerned about that at all. That should be pretty easy and straightforward. What I am concerned about is that 1/32 slot that goes through there. 4 inches, 1/32. And I'm a little concerned about that because, well, that's a tiny little slot. And I've never milled anything that skinny before, especially in steel, maybe aluminum. But yeah, this is the smallest end mill I own. I bought it just for this job, and I forget how much it cost, but it was a couple bucks. So I really don't want to break it. I probably should have ordered 2 just in case. But milling a slot that skinny in steel, I'm a little nervous about. I'm not going to lie. Now, I know it can also be done with a slitting saw. Somebody else, Joe Pye, did it with a slitting saw. So when I was writing my notes here, I wrote down 132nd end mill or slitting saw. This is before I bought any tools. And I decided to try the end mill. For one, I don't have a slitting saw. I know I could have bought one, but I'm going to try this. I'm going to see if this works. So the next question is how do we hold this to mill that slot? And what I'm going to do is I'm going to take a chunk of aluminum. I'm going to cut a V groove in it that'll sit in, and then clamp that down to support it, and then try to mill the slot. So it'll either work or it won't. If it doesn't, I'll probably buy a slitting saw and a slitting saw arbor, because I don't have an arbor either, or I'll just make one. So let me get set up on the mill, and I'll show you how this goes. So be with you here in just a minute. All right, so here's the setup. I milled a V groove in the aluminum block with that. And I got the rod in there, clamped all the way at the other end, because I have to mill that slot about 4 inches down. Now, one advantage of doing it like this is that I know it's going to be centered because I have not changed this, so it's going to be centered on that point. So I know that slot will be perfect down the length of that rod. The disadvantage of this is that that's a lot of stick out from there, and that rod is flexible enough it can lift. So what I did was I glued it down with CA. Now, I have no problems with using super glue, and there are countless other machinists who have no problems using super glue. It works very well if used correctly. So I am very confident that this will hold perfectly fine when I mill that slot. That should not lift or move or vibrate or anything. It should be perfectly fine. I know at least one person who adamantly refuses and is completely against using super glue while machining. And if that's you, or if you don't like super glue, then don't use super glue. I could have just put a thinner. This would be too wide, but I could have put a thinner parallel in the vise and just clamped that right at the top edge of the vise, and that would have worked perfectly fine. But then it would have been a little bit trickier finding the perfect center. I mean, it would have been doable, it would have been fine, but this way's easier. And plus, I didn't think of the other way till after I set all this up. So I'm going to go with this. Maybe the other way would have been more secure, probably. I don't know. But like I said, this is going to be a very fine, shallow cut. I'm going to take extremely shallow cuts, shallow passes, multiple shallow passes. So I'm not worried about this at all. If I'm wrong, then all of you can say you told me so, and that would be perfectly fine. The problem with this is I'm going to have a hard time getting a good camera angle, and plus I plan on using this. I got this a while ago. I've used it a few times on the lathe. It seems to work very nicely. The only problem with this is when you spray it on, it's really foamy and you can't see what you're actually doing. So I don't know how much I'll be able to record, but I'll try to get some footage of it, and I'll let you see if it fails or if it works. So let me get the camera set up, and let me get the cut made, and we'll see how it goes. Okay, so that was just the first pass. It was actually less than 1/10 of a millimeter. I feel like I could have traversed a little bit faster, quite a bit faster, but I've got a consistent mark all the way down, so that tells me that we're good this way. It looks on center. So I'm going to keep doing that. I'll probably go about 1/10 of a millimeter per pass. Maybe if I get a good feel for it, maybe 0.15, I don't know. I don't want to push my luck. But this is going to take a while because, again, that's 4 inches. And that took several minutes. So I think I can go faster. But yeah, I'm just going to keep doing that. I'm not going to film the whole thing because it's probably going to take a while. I'll just let you see what it looks like, maybe on the last pass or after it's done. Okay, there's the last cut. And I'm actually very pleased with that. Nice, clean, smooth slot. And the cutter still looks good as new. And all I got to do now is unclamp it and soak it in some acetone to clean off the super glue, and then put it in the lathe to clean up each end. And you can see my notes over here. So I needed to go 0.8 deep, which is 1/32 and 4 inches long. And I started off really shallow, 0.07 millimeters, and I just went a little bit more and a little bit more until I got comfortable. Once I got to 0.4, I'm thinking, I don't want to go right to 0.8. It probably could have done it fine. I was probably being way too cautious. But again, I only have one end mill, and this is the smallest end mill I've ever used, and I didn't want to take any chance of breaking it. So I just went to 0.6 and to 0.8. And actually, I went to 0.81, figured just a little bit extra wouldn't hurt. So yeah, I probably could have done it in only 3 or 4 passes instead of 6. Maybe 2 passes. I don't know. Like I said, I don't have enough experience with that small of a cutter to find out. And I did not want to experiment with this one, so I just was patient and took my time, and I got a really nice slot going on here. So, like I said, I'll get back with you once that's in the lathe to clean up each end. Okay, so that part is done. As you can see, it's supposed to be 6 3/8 inches long. And right now it's just a little bit, tiny bit longer than that. I think it's within a fractional tolerance, but we'll find out at final assembly. If it is a little bit too long, it'd be easy enough to just put it back in the lathe and shave off an end. And if we can take a look how the slot turned out, how the end turned out. Kind of hard to pick that up on camera, but I'm actually very pleased with that. It was a pretty good view. I'm happy with that. This is one part that, for as easy as it seems, I was a little bit stressed about it because, again, I did not want to break my end mill. This is now officially the smallest end mill I've ever used, which I know for some of you, that's nothing to brag about. But for me, I'm pretty happy with that. Now, like I said, you could have used a slitting saw. A slitting saw would have gone a whole lot quicker. But the way I did it, it was easier to make sure that it was on center. And also the way I did it, I think the end of the slot looks nicer than when you use a slitting saw. Of course, that's just my opinion. You can disagree if you want. And but yeah, there's one more part done. So again, got that one done, and I got that mistake modified, so it just looks like a different type, different style of a faceplate is all. Not really a lot of work in this video, but I'm going to end it here because I really need to get back on another project. But I've been thinking about this one for a while, so I decided to go ahead and just see how that slot would go, and just get that knocked out and done. So anyways, hopefully you enjoyed that or got something out of it. And hopefully this video is not too long for as little as work that was done. But as always, until next time, thanks for watching.